Okay. So let's do a quick revision of what we did yesterday. Nothing much, basic stuff. Uh, okay, so this was one important thing that this guy invented the difference engine. Why is it called difference engine? Because it could do because it could do differentiation by the finite difference method. Okay, and computers required, and yeah, so the basic operation with it, which is what about? No, you cannot do integration with difference engine. So it used to do it with repetitive addition, but the end result was same as doing differentiation. And then we understood what is the programming language, just a set of instructions. Yeah, the computer doesn't directly understand, but uh, there is a compiler or an interpreter in the middle which will help the computer understand. So basically, these languages are of many types, right? We saw somewhere. Yeah. So these are the types of languages. Computer understands this, but we humans usually write this or this. So to convert this to a low level language, we have a compiler. Okay. We'll see all this practically. And then nowadays we also have natural language with the because of AI. Okay, and yeah, the programs are nothing but a set of instructions written in a computer programming language. That's it. Mm. Then this we know it's everywhere. We saw abacus, Napier's bone, Pascaline. These are all just machines. Jacquard Loom, difference engine, and Mark One. Then we start with the generations of computer. This is the von Neumann architecture. This is how we still see the computer. We have a processor, we have program and data, and then there is a channel, and we just keep swapping things between these two things. It happens at very high speed, so we don't understand, but that is what is happening. Then there are five generations, fifth generation being the artificial intelligence, data and information. Information is a meaningful data, right? Then this we know output, input, ALU. So we'll come back to all this when we actually start doing things practically, because I think theoretically it makes sense, but not much. We understood there are two types of memory, primary and secondary. Primary is the RAM, secondary is what these things. Input, output, then there is bus for communication between all the components. We'll start with booting. Okay. So what is booting? Yeah, it has gotten nothing to do with boot. Boot usually means shoe, right? It has nothing to do with that. So, see, when we turn on the computer, we give the hardware some electricity, right? But once we turn on the switch, like in case of a light bulb, the light bulb would just turn on. But in case of a computer, when we provide electricity to the hardware, The very first thing. So the thing that starts happening after we give the hardware electricity is called booting, right? So when we switch it on, what happens is, so there is a ROM in every computer, either inside a CPU or in a laptop or in a mobile phone. In every uh, computer, yeah, all the portable, non-portable servers, even your smartwatches, everything has a ROM. So like even your mobile phone, you can turn it off, right? Like when you restart your mobile phone, you completely shut it down and then you turn it on. So when you are turning on your mobile phone, your smartphone, so your tiny smartphone has a tiny ROM in it, and that this ROM contains the set of instructions which tells ki do this. Like these instructions can be something like ki pick up something from your secondary memory. Like there will be a secondary memory as well, right? Where your operating system will be stored. Like a mobile phone has 32 GB of internal memory, 64 GB of internal memory. So there in the internal memory, you'll have the actual operating system. So it will be written, go look for operating system. If operating system is found there, then uh, double click on it. Like if we have a program in Windows, we usually double click on it to open it. So so all those instructions will be written. Ki, go there, find that program and open it. So those instructions are stored in ROM. Okay. So this is bought into the main memory. Main memory being your RAM, right? So this is called booting. And so when it's bought in the main memory, then it will start its execution. Like it will start checking if all the files are present. It will do a series of checks so that make like if it starts to turn on and then suddenly if something is missing, then it will throw an error and everything will crash. So usually it will check. So there will be a check for everything. If everything is present, only then it will start booting up. Okay, and so once it is in the main memory, then we saw here in the architecture, right? Ki this one. So there will be a BIOS on the motherboard somewhere. Like let's say it's here. Okay, there will be a BIOS somewhere here. And then once the booting starts, the thing from BIOS will be put in the memory. Memory means your RAM. Okay, and this has all the instructions. So now the execution will start. And for execution, the RAM cannot do anything. It will have to use the bus here to give it to the CPU. Then CPU will understand what is there. Like we have ALU, we have control unit. So control unit will manage this transfer. It will tell ki, acha, you have the instructions in the memory. Okay, give it to ALU. Control unit will tell the memory, give it to ALU. ALU will then do all the operations what is there. It will maybe give something back to store in the memory temporarily. Then it will do all the operations. And this happens with every program, not just booting. Booting is just another program. Are you asleep? You're there, right? Okay. You are. Okay. So this was booting. Hope you're understanding what I'm saying. If you have any doubt, you can stop and tell me. Your voice is very low. I'm sorry. No, both. See, into the main memory, and we just saw what is main memory. It's the RAM. It's nothing but RAM.
Yeah. So why is it called main memory when ROM does the like half of the job
No, ROM
or
does not
most
do
of the job?
anything. ROM just stores
So
it,
you
right?
are saying right? No, you are saying
Huh.
it right. Like when the computer will boot itself, then ROM is the one who will just hold on. Like so that nothing crashes and everything stays fine.
No, no, okay. Maybe you missed something. So ROM is just for storage. S- And what does it store?
Hmm.
A very important set of instructions which are needed for the computer to turn on.
Hmm. Hmm.
We do not keep it in the RAM because it's volatile. If you turn your computer off, it will go away. We do not keep it in the hard disk because hard disk, if someone disconnects the hard disk, then your computer is useless. You cannot turn it
Yes.
on. You cannot
Yes.
keep it in pen drive because pen drive is also detachable.
Okay. So ROM is only needed when the computer will like
Yes.
restart itself. Like
ROM is
turn on.
of very small size. It will be like 16 KB or something. And it
Okay.
will be like wired on the motherboard. So it will be like soldered on the motherboard and it will be, you cannot remove it. It's permanently there and it's of very small size. Okay. So when the booting starts, the program from the ROM is just picked up and put in the main memory. That is the only thing that ROM does. Okay. So the data it contains is very important, but it's just another storage thing, right? It's nothing else. It's not any processing thing. It is not CPU. Just a storage. We saw, right, that where did we see memory? It's just memory. ROM is kind of memory. Okay. So what then CPU will first it runs a jump instruction that transfers to BIOS. The BIOS is just basic input output system and it starts executing. So this ROM, so yeah, so this is what I was talking about. Ki BIOS it conducts a series of self-diagnostic tests
Hmm.
to check if it will be able to turn on or not.
Okay. So every time like my laptop was out of order, so ROM was to be blamed, right? Because
No, why?
then like see because I had a lot of laptop which was out of order and it was not getting done.
It was not turning on.
Yes.
So how can you be certain that it was the ROM?
Okay, so there are multiple factors behind this illness.
Yeah,
It
so
can't be
this is
wrong.
this is just the first step, right? That you
Okay.
uh, the boot program is bought from RAM into the main memory, and this is called
Okay.
booting.
Okay.
It's just the boot program. That's it. And then the CPU starts executing this program.
Hmm.
This jump instruction is nothing but it's there inside this boot program. It has started executing the thing which was bought from the ROM to RAM. And then BIOS will do the this post power on self test. It will check if all the memory is working, all the video, audio. You will see your keyboard light up and then turn off. So that happens during this post checkup. It will check your graphic card, all the components. So only if it will check not all the components, it will check only the basic necessary things which are absolutely needed for the computer to turn. So like your RAM should be working, your CPU should be working,
Hmm.
right? Some output channels should be there. Yeah, your input devices should be working. Okay. Thereafter, the BIOS locates a bootable drive to load the boot sector. So, see, now once they have this boot program has done the basic checkup, कि now the computer is ready to be turned on. Now it will try to look for a secondary memory. So
Okay.
bootable drive is a it's always it can be primary, but no people you can do it, but no one does it. So 99.9% time it will be a secondary memory like a pen drive, a hard disk. 99% time it's a hard disk. Some people use pen drive, but pen drives they are very slow and there are disadvantages. So it will locate the bootable drive to load the boot sector. Boot sector is nothing but the place where the operating system is stored. And why they are calling it a sector? Because when you look at a hard disk, yeah, you would have seen there is a disk inside. I mean, it has disk in its name, right? Hard disk. It's hard and there is a disk. So disk is actually the circular disk. There is a physical disk inside the hard disk, and there is usually a this thing which points to this. And in mathematics, you would have studied what is a sector.
Yes.
This is a sector, right? And this is a segment, but this is a sector.
So what is
So,
the connection?
sorry.
So what is the connection?
Yeah. So on this whole disk,
Hmm.
this BIOS will find on which sector. So there are a lot of sectors, right? And in
Yes.
every sector, different kind of data is stored. You can store anything.
Hmm.
So in which part? So in which sector
Hmm.
is the operating system present? The BIOS is responsible to find that out. It's BIOS's responsibility. Okay, and once you find that, then all good. Then now this hard disk will take over. So the execution is then transferred to the bootstrap loader program on the boot sector. So right, so this boot program's task is done. So all the instruction in the boot programs are executed. So boot program had a uh, there was a jump instruction, then there was a post, then it found the bootable drive. Okay, then it is transferred to the bootstrap loader on the boot sector, which loads and executes the operating system. Okay, if the boot sector is on the hard drive, then it will have a master boot record which checks the partition table for active partition. If found, the master boot this MBR loads the partition's boot sector and executes it. We'll see what exactly is all this, but so like you understood, right? There is a boot sector. Now inside the boot sector, uh, the bootstrap loader program it will load the operating system, right? The boot sector is nothing but the place where operating system is stored, right? You know what a operating system is, right?
Yes.
Can you give me some examples?
Uh, Operating system.
Yes.
Are you checking my knowledge?
Sorry?
Are you checking my knowledge?
Yes, yes.
Okay, so such as Windows 11, Windows
Okay.
7, is
Anything other
I
than
Windows
Windows? Anything other than Windows?
Mac.
Mac.
Yes.
What exactly Mac? What is Mac?
Like Mac operating system.
Okay. Mac OS. Hmm.
Yes.
Okay.
So even Android can be operating system.
Android is the operating system.
Okay.
It's based on Unix, right? Then we have
Hey,
Linux as well.
Linux, yes. Then you talked about Ubuntu also.
Yeah, Ubuntu is one of the operating systems in Linux ecosystem.
No, you said that these are open source.
Yeah, they are open source and free, but Windows is not free. You have to pay money
Yes.
to get that. So, right. So the like when you download Ubuntu, it is of 2 or 3 GBs.
So, but why do I need to download?
So let's say uh, right now you have a computer, you have Windows running on it,
Yes.
and let's say you want to run Linux on your. Let's not get into why would you want to do that. People do things, right? So
System of yes.
so if you want to put Linux on your machine, then you'll have to first download the operating system.
But if I already have Windows, then okay. Okay, yes, okay.
I told you right that people have reasons. People do
Yeah.
things. So let's say
Are
you
you one
just
of the four?
yeah. Let's say you ran out of money and you can't pay
Okay.
for the Windows subscription because it's 6,000 per year.
Yeah.
Okay, Linux is completely free. So now you download Linux. So it's usually of 2 or 3 GBs.
Hmm.
Okay, so you'll keep it on a hard disk, right?
Yes.
Right. So it will and you'll have to create a bootable drive
Hmm.
so that the BIOS can locate it and it is transferred to the bootstrap loader, which is there on the boot sector, which loads and executes the operating system.
Yeah.
And usually there is a master boot record that
Yes.
loads the partitions boot sector and
Executes it.
mm. So see these things. What actually is happening is on the hard disk there are sectors, right?
Hmm.
And they are not contiguous, so you'll have to keep address and memory of. So let's say uh, your operating system is on this sector,
Yes.
okay, but your master boot record is on this sector, this one.
Okay.
Okay, so in the actual code, like in this boot program or whatever program this bootstrap loader is, you'll have to point to the address key here, that thing is present. So you'll have to write a line of code to point to that address key. This is the place where that program is, so your next execution should start from this place. So this is why we have these many steps. So we are just doing all that, and these are just names of things we have just named it so that we can communicate. There's no other
Yeah.
utility to all this partition and all that. Like if you would have installed any operating system, you would have seen these things, you would have heard about these things.
No, but I already have Windows. So what are the things like that? How would I use for this partition in
It's
Windows?
fine, I mean, not needed. See, there are two types of what is cold booting when the system starts from initial state, that is switched on. We call it cold booting or hard booting. When the user presses the power button, the instructions are read from the ROM to initiate the booting process. This is cold booting. So what we saw above was nothing but cold booting. When the system restarts or when reset button, called it warm booting or short. The system does not start from the initial state, so all the dynamic need not be carried out. Okay, like when you restart your Windows, the operating system already knows okay, we have to turn back on again, right? Like if I click here and go to restart,
Yes.
right? So the computer already knows कि I have to turn back again. It will not trouble the BIOS unnecessarily. It will keep it in memory uh, and turn back on. So it will be warm booting. And your mobiles, your smartphone also warm boots, like when you put it in standby and turn the power, press the power button, then you can we can say it's kind of warm booting.
Yes.
Okay. So these there were a lot of technical terms here. Okay, just don't worry too much about all this. Just remember there is ROM. It brings when we start booting, the boot program is bought from the ROM into RAM. Okay, and then BIOS does all the checking and everything, and then it just locates the boot sector on the hard disk where the operating system is there, and then it will load the OS. Okay. This is the basic how your computer starts from the software perspective. This is of I don't think digital. All the computers we see are digital. The analogs are long gone. Okay, hybrid is both. This is also useless micro mainframe. Mainframes are basically large servers. We don't keep these things in home. Like Amazon has AWS,
Yes.
right? So
Yes.
all the EC2s or anything you see on AWS, it's all just mainframe. Okay,
So,
just not.
like,
Hmm.
why can't I open ChatGPT or any other AI like in my lab?
You can't
Why does
open.
it stop me?
So what do you mean?
Why
It's
does it say? Why does
hmm,
it say that like you're not
you are not.
permitted to do this?
Yeah, so there would be a firewall or there would be some restriction put on the admin because you're not the admin of that PC, right? So admin can add restriction. Okay. So there is a thing called RBAC, role based access control. So you have a basic user's role in your computer, and the admin of that
So I really
computer,
want so that the admin of the computer, does he actually know what I text people on Slack?
not really, but the security team can find it out
Check.
because of security concerns, just to check if you're not leaking anything. Okay. Okay, let's do this. At least four early come on.
Uh, Advocates,
And
and I got difference in them. Maybe ask these. And there was I told him the difference in them.
and quick.
And what?
There was a Pascaline analytical engine. Okay, but not that important anyway,
Then why are you asking?
because we wasted time studying all this.
Yeah, it's all
If name the first operational general purpose computer.
difference in them.
Okay, even I'm not sure. So who proposed the concept of stored computer program? Okay, this was I think. Do we have the answers? We don't. Are you sure? What is this? Okay, no answers, I think. Okay, solved examples. Okay, so this we can find out if we wanted to, right?
but we don't want because we are not sitting for any board exams.
Exactly. Hmm. Define IPO is what is IPO?
And things I know it every time.
Mhm. Initial public
It's
offering.
in it's input process output. I was going to
Yes,
say it.
yes. Input process output. Yes. This we know, right?
Yes.
What is it? Tell.
Yeah, it's like data is a random thing, but information when you put the data in the right format. Like Raju is so there will be data like Raju plus 9 and this and that. But
Hmm.
if you say that Raju is going to be plus 9 this year, then it
Hmm.
will be a perfect information.
Okay. Information is meaningful data.
Yeah. But
One
I'll
new
give
man.
examples.
Yeah. Thank you. Uh, One Newman computer.
I don't know.
We saw
So
this,
it's a
right?
very huge, yeah, it's a very huge computer. You said that if you are in a 1 PHP, then
No,
you will
no,
just
no.
have H and K.
One Newman computer. I mean, he
It's
gave
very
the
huge.
architecture.
Yeah.
That was not the computer which was very used. That was a Mark One or something. Von Neumann is computer gave the basic architecture which we use even today. So it was the that one. That there will be a processor, there will be memory, there will be input, there will be output. So that architecture is von Neumann. Okay, computer. This is functional components, functional booting process and its type, digital. Okay, okay. Types of software: system, application, utility. Okay, system operating language. So this is what I was talking about.
Yes.
Language translators are high level to low level. Okay, this is little important. To convert high level to low language, we have language translators. We have these three. Assembler is for assembly language to machine code. What is machine code? Zeros and ones. Okay. Operating system, you know. Utility is this. General purpose customer. These are not that much important. This is important for us. OS and language translators. Operating system is a subject in itself. We'll go through it. These are the examples. Um, Need is very much functions. Yeah. So processor management. Okay. There is so what do you think and what does an OS do? How what do you think?
Like whatever you want. So it's like a slave to us.
It's like a
Slave to us. To humans.
no, I'm not able to understand what you're saying.
Slave, slave.
It's a slave.
Yes.
No, computer is a slave. Operating system is a software.
So see,
See, if you tell the computer to do something, operating system will not like if you tell the computer to do 2 plus 2, Operating system won't do 2 plus 2. This is something you should understand. 2 plus 2 will be done by the hardware which is there.
So
Operating
what
system
is
will
operating
enable you
system
to,
doing?
yeah, operating system will enable you to pass the instruction to the computer. It is a mediator. See, it provides a platform on top of which other programs and can run, right? So it is a platform or it's a mediator.
It's a movie.
Okay. It acts as an interface. Interface is the
It's a
right word.
dalal.
Dalal. It's a interface between the computer and the user. So as I said, this is the slave and you are the master. OS is
That's
just
what
an
I mean.
interface between the two. Okay. So it is designed in such a manner that it operates, controls, and executes various applications on the computer. So like the Chrome or any Slack, anything which you see here, this are application softwares, right? So they need a operating system to run. They can't run independently on your computer. Okay. So once you let's say you buy a dabba, which is the hardware, and you come to me and you tell me I want to run Chrome on this dabba. You cannot run Chrome on this dabba. You need an operating
That's what
system.
happens.
Yeah. Okay. All these things you need a OS to control. See
So
our
is it like a supervisor?
yes, exactly. See you would have heard ki the iPhone it only has 4 GB of RAM, whereas and but it costs like 1.5 lakhs. Okay. And for 1.5 lakhs in the Android ecosystem, you will get like 16 GBs of RAM, right? If you buy Samsung Galaxy, correct? Maybe they will give you 6 GB in 1.5 lakh to take the Pro Max version. I'm talking about the primary memory. Okay. What is primary memory? Bhagwan Ram.
No,
Okay.
RAM will be
What? Are you saying something?
Am I not audible?
No, no, no. I'll send you the recording and then you can see. Okay. So what did you say? Just be try to be loud. At least for this session, we'll see what will
Okay,
be.
so what I'm saying ki
Hmm.
RAM is supposed to be the main memory, right?
Yeah, primary memory is the main memory.
Okay, okay,
Primary memory, main memory, and Bhagwan Ram. All they all are the same thing.
same thing. And the ROM is the secondary.
ROM is not secondary memory. Uh,
Why is there so much?
I'm
एक
not
है
sure how
RAM
do
है
you
इधर ROM.
ROM is primary or secondary. It's a good question. I mean, I'm not sure. It is primary. Right. It cannot be secondary. I was skeptical because uh,
So why can't it be secondary and what is the criteria of being secondary?
see this is great. It's a type of non-volatile primary. See, it stores the essential instruction, right, for booting,
Yes, yes, yes.
and its contents are retained even when power is turned off. Unlike RAM, which is volatile
Okay.
and used for
Mm-hmm.
temporary and actively processed data. ROM provides
Yes.
permanent storage for form. So it's slower than RAM but faster than secondary memory.
So now what is the secondary?
What is the difference between primary and secondary memory? See, this is what I was looking for. See, while booting, the CPU accesses the ROM, picks up the data, and puts it in the RAM. The bootstrap loader, that thing picked it up from the ROM and put it. So the CPU was accessing it. So this is the main thing. This is the differentiator.
Not direct-
Sorry?
Okay, not it is not directly accessed by the CPU.
Yes, this is the important thing to remember. You should probably write it down somewhere.
On my forehead.
Not it, right? Mm. So now we don't even need to remember ki is hard disk a primary memory or secondary memory. Hard disk we know it is never accessed directly by the CPU.
So
Uh,
it's secondary.
it is secondary. Okay, so where else? Yeah. So here iPhone is able to give the same performance as the Samsung Galaxy, which has 16 GBs of primary memory, and this only has 6 GB. So there is
Hmm.
a difference of 10 GBs here,
Hmm.
but the price is same.
Hmm.
So is iPhone people, is the Apple ecosystem just cheating money or what are they doing? But they are able to
No,
give the
I
same
think
performance,
yeah, the
right?
OS is making the difference.
Yes. So it's all about the operating system. So if your
So can we
supervisor
make
is
one
good, so yeah, we can make operating system. If you want, we can actually build one as well by the end of this course.
better than the Mac OS?
Uh, that is debatable, but yeah, I mean, if you want to, then you can definitely do. Because there are like thousands of people working, so if you want to compete with them, a little difficult. But we definitely can. So,
But
right?
then we can make more money.
Yeah, yeah. So operating system is the supervisor. If your supervisor is good, or maybe the supervisor knows. So actually, this 6 GB of RAM and this 16 GB of RAM is not exactly the same. There are some hardware differences as well. So what the Apple people do is they make sure that the operating system is designed as per the hardware that they use.
Okay.
Okay, you cannot swap a Samsung Galaxy RAM to an iPhone. Impossible. It's never possible because it's not designed to be put in this thing. The CPU will not be happy with this RAM. This is cheap RAM. This is then. So nowadays you have unified memory. That concept is not there in this Windows and Android ecosystem. Unified memory is your graphic card and RAM. They both can be swapped. That is another thing. But what I'm saying is, if your supervisor is good and it works according to the hardware, then you can squeeze out better performance. Okay. So this is what CPU does. It does processor management. Okay. So
So
this is
it
what.
also acts like managing.
Yeah, diagram. So it will do see this all priority scheduling. So you have a lot of tasks. If you have 5 tasks at your hand, how are you going to do it? So that the end user feels maybe you have a client. In this case, the client is us, right? We tell the computer to open 5 tabs of Chrome. Now the operating system will decide how to do it. Apple, the Macintosh OS will do it differently, and the Android OS will do it differently. Okay. So this is the
So the earbuds that I'm using currently. So can it be connected with the iPhones?
yes,
Are you sure about
yes. See, why did I say yes? You should ask this.
it? Yeah, exactly. Why? Because I heard it otherwise.
See. we just studied about bus, right, in the previous chapter.
Yes.
So bus is a communication channel. Your earphones are communicating with the laptop or the smartphone through a particular communication channel. Which channel is it? Can you tell it to me? Which channel is it?
Okay.
Yeah, Bluetooth. So does iPhone also have Bluetooth?
Yeah, I guess. Yes.
It does. And Bluetooth is a separate technology. It has nothing to do with
It will
uh,
be TOOTH.
thanks for that, but yeah. So what I was saying is this Bluetooth,
Yes.
it is the same technology which is used by Windows, by Android, by Macintosh, by iPhone. In Linux also you have Bluetooth. So this is a different thing. It has nothing to do with the iPhone. And you would have heard
Mhm.
there is Bluetooth 5.3, 5.2, all that,
No,
right? So
no, I have not heard of.
there is Bluetooth, like if you go uh, for buying a smartphone, it will be written this smartphone supports Bluetooth 2, Bluetooth 4, Bluetooth 5.2, something like that. This is a separate technology. So because your earbuds are using this bus for communication, so
Mhm.
even in an iPhone you will be able to use it. Even in a Linux device you will be able to use it. You might face some issues with drivers, but we driver is nothing but a software. So we can always change a software and make it work. But you won't have to. They are usually compatible. Okay. So because the channel is a common channel which is used by all the smartphone builders, you will be able to use it in an iPhone as well. Good question. I like that question. Round robin. So
Understood.
the manager, the operating system is a manager. It has to
Yes.
manage a lot of tasks. It doesn't manage people, right? Because
Yep.
it's our slave. What does it manage? It manages processes and processors. You using the processor. I'm not sure if this should be processor or it should be process. But anyway, okay. And this, what is scheduling? Scheduling is just managing these processes. So sometimes we can give priority. Like this has priority one. This has priority 10. So if someone has higher priority, it will be executed first. In round robin, we usually take it one by one. Okay, so this is round robin scheduling. So this is just a way, an algorithm how we schedule. We'll see all this in action. Device management. You have a device manager on your computer, right?
Yes.
So OS is responsible for managing all the devices, all the Bluetooth devices, all the USB devices, keyboard, mouse, printer, everything. Okay, so
Yes.
I think this is important. Communication hardware and the attached devices and maintains a balance between them and the CPU. Okay, this is all the more important because CPU processing speed is much higher than that of IO devices. Important point, very important. Hmm. Balance. Okay, did you understand this? Hello.
Okay. So, what are the attached devices here?
Keyboard, mouse, printer, headphone, earphone. IO means input output device.
Okay. Got it.
Okay. So operating system. So like I'm moving the mouse here, and you are able to see this thing move. The operating system is doing something in the background. Only then this is being possible, right? I'm physically moving my hand here.
So what if your laptop suddenly hangs? So it means the operating system has also something.
Correct, most probably. But sometimes you would have seen only this browser is hanged and you are able to access other things.
No, not necessarily. Like it doesn't happen. Like when the
Sometimes it can.
entire laptop.
Like if I open a lot of tabs here, this. If I keep opening tabs, if I open a lot of tabs, see. So there is a high probability कि this browser is going to hang, but the other parts of my computer will be working. Okay, that can happen. So in that case, operating system is still working. The application software is not working. Okay, but yeah. So most of the time it's the OS that is hang. So these scheduling algorithms, right? So there can be a deadlock. We'll study about it. They can at times hit a deadlock. It's a very interesting thing. And because of that deadlock, your computer can hang. And you will have to turn it off and boot it again. That is the only solution because that is what a deadlock means. It will never resolve. It will be stuck forever. So that is why restarting fixes it.
So what if you could not even restart it?
I mean, if you take the plug out from the socket, the computer will turn off. It needs electricity. There is no electricity, it will die.
No, I'm talking about laptops.
Yeah, take out the battery.
Oh, I don't
Okay.
know
And
this is
usually
something.
the reset pin which you have on the back of the laptop,
Yeah.
all that is doing is just
So we literally
disconnecting the
have
battery.
reset pin.
Yeah, have you not seen it?
No, never.
Like if you have another laptop lying around, you can just turn it around and see. Even in your mobile phone, it's there. Nowadays,
There
I'm
is
not
no
sure
reset pin.
if they give it.
Oh, there
We'll
is no
have to.
reset pin in my work laptop.
Okay. Usually they have. Okay, in my laptop it's there. In most of the laptops it's there. So what that reset pin does is just disconnects the power supply from the battery so that it actually resets. Okay. On your Wi-Fi routers also you will find there it would 100% be there.
Yes.
Yep. So in order to optimize the CPU time, the to buffering and spooling. You would have heard buffering, video buffering. Back in the day when the internet used to be slow, the video used to buffer. So in this technique, the temporary storage of input and output is done in input buffer and output buffer. Once the signal for input or output is sent from to or from the CPU, the operating system through the device controller moves the data from the input device to the input buffer. Yeah. Okay. So I need to go somewhere. Let me first. 1 second. Okay.